Welcome to course 62 of course 2. In this lesson, we're going to be dealing with triangles and classifying triangles. We're going to classify them by their angles. We're going to do the order of the sides of triangles from shortest to longest when given only the measures of the angles. And we're going to classify triangles by their sides. Please do not skip this lesson and just go to the TIDs because it is, I promise you, it is nothing you've ever seen before, and it's going to really surprise you because it is new content. Okay, so let's start with some stuff that you should already know for the most part. An acute triangle is a triangle whose largest angle measures less than 90 degrees. Here we've got an example of an acute triangle. Then we have two examples that are not acute because they are not less than 90 degrees. This one is exactly 90 and this one is obtuse. It's more than 90. An equilateral triangle, all three sides are the same, and the way we know that is you'll see how they do these little special markings, how they all match up. That means they're all these same sides are identical and all these same angles are identical. That's called an equilateral triangle. An isosceles triangle is a triangle that has at least two sides that are equal length. So these both are the same. And what we're going to learn in this lesson is that this applies to this and this applies to this, and that's why these two here are the same and this one is not, and that's an isosceles triangle. All right, then we have an obtuse triangle, which angle is greater than 180. Again, here's our obtuse, here's our acute triangle, it's less than 180, and here's a right angle that's not, it's 90, so it's not more than 90, it's right at 90, so it's not obtuse. And then a right triangle is a triangle whose largest angle measures exactly 90 degrees. And then we have a special triangle where all three sides are of different lengths, and it's a scalene triangle. And sometimes it's hard to tell whether this is a right triangle flipped on its side or a scalene triangle. Usually you're going to have to measure it, or it's going to have to tell you the lengths to be able to tell that. But we'll do that in this lesson. All right, so you recall from lesson 7 that we classify angles as acute, right, or obtuse angles. We use the same word to describe angles that contain these angles, triangles. So when we classify triangles, we do it the same way. We have an acute triangle because it has an acute angle in it, right here. We have a right triangle because it has a right angle right there, and we have an obtuse triangle because there's an obtuse angle right there. All right, so when describing triangles, something they do a little bit different is that they refer to the sides and angles as opposite each other. For example, we might say the side opposite the right angle is the longest side of a right triangle. So let's look at that right now. So that side right there is the longest because this is the largest angle. So this would be AB, and this would be angle C, but side AB. And the opposite side of the largest angle will always be the longest. The opposite side of the next one will be the next to longest, and then the other one, the very smallest angle, will have the shortest side. And we're gonna practice a few of those, and you'll get the hang of this. But it's not something you want to skip. Okay, so let's just start by naming the sides of this triangle in order from shortest to longest. The first thing we have to do is we have to figure out what y is. Well, how many degrees does a triangle have? That's right, it has 180. So we just got to add up all our corners to total 180. So if we've got 121, we take away 121 and we subtract it from that, we're going to end up with 59. So we know that W is equal to 59. So now we just got to put them from shortest to longest. Well, it says name the sides. So the shortest side is going to be opposite the shortest angle. Our shortest angle is 59, so we're going to go opposite to right here. So that's going to be YX. That's our shortest side. And 60 is our next shortest, so we're going to go over here to find our side. Right, there's our side, and it's YW. And then our longest is WX. That's different than anything you've ever seen, isn't it? So please pay attention to this lesson so you can get it down pat, so you don't have any confusion when they're asking you about sides of a triangle. And it's how we did it exactly right. Okay, so which sides of this triangle are the same length? So apparently there's two that match up. This is an isosceles triangle because it has two sides of the exact same length. Well, which sides are they? Are there two that are 58 or two that are 61? How would you solve it? Stop the video and solve it and see if you get it right. Okay, again, I know that my triangle makes up 180, so I've got to subtract 119, it looks like. 119 from that. Let me make sure. 8 and 1 is 9. 11. Yep, 119. Okay, I'm a 7. I'm a 10. I'm a 1. 61. So that means Q must be 61. So it says which side of this triangle are the same length? Well, it's going to be side SQ and side SR. Did you get that? You probably said Q and R, but did you get the sides right? SR and SQ, that's right. Okay. If all three angles of a triangle are the same measure, then all three sides are the same length. So if triangle JKL here that we have on the right, if JK is equal to KL and KL is equal to LJ, so if we can say this, that they're all the same, we got an equilateral triangle, don't we? So how would we find either one, any of these measures, J, K, or L? In this case here, it just asks us for J. Well, again, how many degrees does a triangle have? 180. And how many angles do we have in this triangle? 1, 2, 3. You're going to divide it by 3. You're going to come up with 60. So no matter what they ask for here, all three of these are 60 degrees. All right? Okay, so the triangle in example 3 is a regular triangle. We usually call a regular triangle an equilateral triangle. As shown below, the three angles are all measure 60, and that's what we just talked about. The tick marks indicate equal length, and the tick mark in the arches indicate equal angles. So, or measures, angles of measure. So down here below, if a triangle has at least two sides that are the same length, and in this case here we have 70 and 70. This is an isosceles triangle. Here 45 and 45, so it's an isosceles triangle. Here we have 40 and 40. So these are all three isosceles triangles because they have two sides that are of the same length. Now in this case here, they're the same measures, aren't they? The lengths might be 10 and 10, or 38 and 38, but the angles are the same. That means the opposite sides. That means that one there and that one there are both the same length, which makes it an isosceles triangle. So if the three sides of a triangle are all different lengths, meaning that none of the sides are the same, then they call this a scaling triangle. Isosceles has two of the same, equilateral has three of the same, scaling has none the same. So the perimeter of an equilateral triangle, so think of the definitions we talked about, is 2 feet. So first of all, what is in it? How long would each side be? So a couple things you got to do here. You're going to have to draw the triangle right. You're going to have to convert feet to inches, and then you're going to have to figure out how many inches on going around the perimeter of the triangle that you drew. So let's start with the triangle. What's equilateral mean? That means that all the sides are the same, and that's probably not perfect, but I can tell you that they're all the same by doing this, can't I? Now you know that that's an equilateral triangle. And it says all the way around it is 2 feet. 2 feet is equal to how many inches? Because they want to know how many inches long each side is. Well, 2 feet is 24 inches. And if we have to go, how many sides do we have? We got 1, 2, 3 sides. So when we divide that, we know that each side is going to be 8. 8. That's our answer. 8 inches. Make sense? I sure hope so. Bring your questions tomorrow in class if you got any questions. Now draw for me an isosceles right triangle. What would an isosceles right triangle look like? Well, it's not an equilateral triangle because that's got all three sides the same. Here's your clue right here. Okay, so let's go ahead and we're going to draw our right angle. It's got to have two sides of the same length. So hopefully those are the same length, and then it's got our third one right here. So I think that's a pretty good look of isosceles triangle. I could do this to make sure you know that it's not that it is an isosceles right triangle. All right. What is the measure of each of the opposite sides? So we drew this, remember? So what is the measure of the angles opposite the sides you drew? So that means what's this angle here and what's this angle here? Well, go ahead. See if you can't pause it. See if you can figure it out. All right, now you're back. Welcome back. All right, so we know this is 90. We know the whole thing is 180. The whole thing is 180. So these are both going to be 45 and 45, aren't they? Is 90 plus 90 is 180. All right, let's see it. Here's your practice to see if you got it down. Describe for me what angle A is. What kind of angle is that? Does it have three sides the same length? No, it doesn't. So it's a right triangle. What would B be? Angle B. Does it look? What do you think it is? It's an obtuse triangle. And angle C is an acute triangle. Now describe each triangle by its sides. Okay, so these ones we did by the angle, right? We did the angle. Right angle, obtuse angle, and an acute angle. Obtuse angle and acute angle. Right? So this one here we're going to do by its sides. So if all the sides are different, what is it called? It's called a scalene. If all the sides are the same, what's it called? Equilateral. And if two are the same, it's called an isosceles triangle. All right, there you go. Submit these to me tonight. Bring your questions tomorrow in class. Thank you for watching the video. Go over this together. Later.